Hello everyone, here we have another Physics 30 example, this time from Unit 4, EMR, and this is Lesson 3, which is Reflections from a Mirror. We won't get into the details about why light reflects or what exactly is reflecting. We'll cover that in class. There's some interesting stuff to talk about there. Really what we're going to do now is just show the mechanisms of a reflection, and of course kind of going back to junior high here really, but of course reflections mean that the angle, let's write it here, the angle of incidence, that is the angle relative to the normal line of the ray coming into the mirror, is equal to the angle of reflection. Let's go ahead and put reflection on there, because we don't want to get that mixed up with refraction, which is coming next. Anyway, it's important to keep track of which angles we're talking about. This angle in the question here of 21 is actually not the angle of incidence. So don't make this mistake. It's quite common when we get into Snell's law stuff to use the wrong angles. We're always, just by convention, we're always using the angle relative to the normal. So let me just go ahead and put a dotted line in to be my normal line. So it's going to be here. There we go. And now I can go ahead and put my reflected line in. So let's see if I can get this approximately right. Obviously, if I was doing this to scale, I would want to use a protractor, but let's not worry about that for now. So here's my reflected line. It's going to be incident now on mirror B. And let's just indicate which angles we're talking about. So this angle here, this is going to be the angle of incident, which means this angle here, this angle is my angle of reflection. Okay, of course what we can do is we can say that this angle is also going to be equal to 21, since these two angles are the same and we're dealing with 90 degrees from our normal line. That one there must be, this one here must be 21. Okay, we're trying to find the angle of reflection off of mirror B. So let's just carry on this incident line here. It's going to go this way, of course. It's going to be incident on mirror B at this point. And so once again, I want to get my ruler out and do a 90-degree normal line in a dotted line. So there we go. Right here, this is my normal. And so I can now say that this, let's use red again. Actually, let's use green. We're going to say that this angle here, this is now my angle of incidence, and this, well, let's put the reflected ray on here as well. It's going to be right here, and so I can say that this is my reflected ray, which means this angle in here is going to be, look at that, this angle in here is going to be the angle of reflection. There we go. Okay, so what have I got? I've got 21 degrees in here. I don't know this angle or this angle, but if I did, I could then figure out the reflection off the mirror. Notice it says an angle of reflection off the mirror. I think that means that we need to know this angle here. This is the angle off the mirror. Okay. Of course, I know that triangles have a internal total angle of 180. So if I was to add up all of the angles inside of a triangle, no matter what the shape of the triangle, I should get 180. Assuming that we're in Euclidean geometry here, which of course we are, because it's a flat sheet. This angle here is 76, so I can say that 180 minus 76 is going to be this angle in here. Well, of course that's going to be 104, so I can label that. This one's 104. So let's keep track of this. I've got, if my total should be 100, so the angles inside the triangle equal 100, I'm going to subtract 104 and I'm going to subtract, so 104, and I'm also going to subtract 21, and that should give me this, let's use blue here, this angle here, let's call this angle 3. It's the third angle in my triangle. So that's going to equal angle 3. And so if I do that, I get 55 degrees. Well, of course, if this angle here is 55, then this angle over here must also be 55, and that's the one I was looking for. So that's convenient. So this angle here is 55 degrees.